Today is day 22, Thursday, and I'm going to talk to you about a review for a test that you're going to be taking either today or tomorrow, and kind of break down to you all the different parts. So the first part that's really important is to find out the rate of change. So if you look here, this is kind of all one section. And what you're going to definitely need is your calculator. So they're telling us that f of x is radical x plus 3, and we have to basically plug in the 2, plug in the 5, plug in the 10, figure out what the f of x, what the y values are going to be, and then we're going to find the rate of change from that. So grab your calculator, and the first thing you're going to do is make it almost like, you know, that's your x, that's your y chart. Let's plug a 2 into here. So 2 plus 3 is 5. And the square root of 5 is 2.24. Then I'm going to do the same thing. I'm going to plug in a 5. So 5 plus 3 is 8. Radical 8 is 2.83. And then I'm going to plug a 10 in, which gets me 13. The square root of 13 is 3.61. Okay, so that's the first step. So if I just asked you for f of 2, you would say that's what it is. If I were to say what's f of 5, there you go, and f of 10, there you go. In this section, you are going to want to convert them into decimals. Now, if I ask for the rate of change, what you're going to be doing, and the question will be written like this. So this is saying, what's the rate of change between 2 and 5? So we're just going to be using that part. And what you do is you find the difference. Okay, well, what's the difference between 5 and 2? 3, and what's the difference between 2.83 and 2.24? And I got 0.59. Now this question is just asking me for the rate of change there. So I'm going to go ahead and say 0.59 divided by 3. And that's going to get me that's going to end up being 0.2 because of rounding, because the 6, you know, that all kind of rounds up. Okay, so that is my rate of change for this one. For this one here, now there you've got to make sure you look at these questions, because sometimes it'll say going from 2 to 5, sometimes it'll say 5 to 10. Now it's saying all the way from 2 to 10. Okay, so once again, we're going to have to go back up here, and we're going to find our rate of change all the way going from 2 to 10 and from 2 to 10 here. So the difference here is 8. The difference here, 3.61 minus 2.24 gets me 1.37. So when I'm finding the rate of change here, I'm putting 1.37 divided by 8. And I got 0.17. And that's my rate of change. So that's one of the sections, is just going to be talking about the rate of change, and we did some of that last week. All right, it's pretty standard, nothing too crazy. Okay, so square root functions. So last week we talked about square root functions, and you guys took a quiz. You did pretty good on it. Here are some basic things that you need to know about square root functions. Then the same thing for cubic and absolute value. And so I'm just going to kind of run through a few things for you. So remember, this is what the basic parent function looks like for a square root function. Make sure you know your transformations. That means if I were to say something like f of x, move that over, f of x, you know, is the parent function, and then I said equals the square root of x plus 2, you need to know that because that's under the radical, that this is actually going left 2. So it would move it over left 2. Okay, remember we worked on that. And then if it's moving up, down, left, right, those kind of things. Also for the domain and range. So remember, the domain is going to be the x values. So you can see it does not come over here at all. So if you were to flatten this thing out, it would go up all on the x. So your domain is going to be x is greater than or equal to 0. For your range, this does kind of go up a little bit. I mean, it looks like it flatlines, but it does not. So you are going to say for your range, x is above 0 because it is going up here. Okay? For your x and y intercepts, this one it's 0, 0 because it's going through the y at 0 and it's going through the x at 0. And then is there a minimum or maximum value? Well, yes, there is, but specifically there is a minimum because there's a bottom here. Okay, remember that with transformations, transformations, if you had something like 3 radical x, then that would make it a vertical stretch because it is bigger than 1. And if this was 1/3, it would be a vertical shrink, which means it would get flatter. So a vertical stretch goes higher, it goes closer to the y, and a vertical shrink goes flatter, closer to the x. Okay, so just remember all those stuff that we did a lot of that last week. And then with cubic functions, it's the same concept. Parent function, this is the basic parent function. Know your transformations. What makes it go up, what makes it go down, left and right. The nice thing for the domain and range for both of these, for cubic functions, for both domain and range, is it's all real numbers. Okay, so that's for domain and range of all cubic functions, even if you move it up or you move it down. Minimum or maximum, there isn't a minimum or a maximum, because these are going to keep going up, 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 slightly up and slightly down. Okay, all right. Absolute value functions. So remember, absolute value functions look like V's or upside down V's. So what would make it flip over? If you had this right here is the parent function, f of x equals the absolute value of x. So if I put a negative in front, it would flip it over. If I put a 3 up in front of it, if I did this, it would make it stretch closer to the 0, to the y-axis. If I put a number smaller than 1, if I put a half here, it's going to make it go flatter towards the x. Okay, if I put a +2 in the absolute value sign, it's going to move it left 2. If I put a 2 on the outside, +2 on the outside, it's going to shift it up 2. So just remember your transformations. When it comes to domain and range, same concept of, if you look here, the domain is going to be all real numbers because it's going on and on and on that way. The range is greater, y is greater than or equal to 0 because it's going up. It's not going down here at all. Okay, the x and the y-intercept, well, this is 0, 0 because that's where it's going through. Remember, if this was shifted up to, it just wouldn't have any x-intercepts. That's okay. They don't have to have x and y-intercepts. And then, is there a max or min? So for this question, yes, there's going to be max and mins with absolute values. With this one specifically, it has a minimum because it has a bottom. If I had a negative here and this thing flipped over, then it would have a maximum. Okay, so if you just picture what that would look like. Okay, and behaviors. So remember, if the polynomial has an even x, if the largest degree is even, so if you had something like x to the 10th plus 3x to the 4th minus 2x cubed plus 1, if you had something like that, you would say the degree is 10. And because that's even, you know that the end behaviors, they go the same direction. Because this is positive, you know that it's going to end up being, something like that. That's not really too sure about how many zeros we'd have, but, it would go, the ends are going up. So if I see something where the ends are going up, I know the largest degree is going to be even, and this is going to be positive. On the flip side, if this guy right here was negative, they would both still be going down, something like that. Okay, if they're odd or even. So I like to go back to think of a linear function. If a linear function is positive, it means it's going this way. And remember, if you write your name on it, it's going up, so it's positive. Well, just use that same idea. If they're odd, it's going the opposite direction. So I know it's either going, that way, whoops, or this way. Well, if we think about it for a second, if it's odd, like let's say it's to the 5th degree or something, right? We would know that it's starting off going down, it's going to end up going up, and then it might have, something in between, some kind of, but I know that it's going to be just like a linear function where it starts off going down on this side and ends up going up. If the first guy is negative, if this was a negative, then that would be flip-flopped. It would start high and then go low. Okay, this is the last little thing I wanted to refresh your memory on, and Right here, if it asks you for the solutions, remember, just set everything equal to 0. So x is 0, x plus 3 is 0, x minus 4 is 0, x plus 5 is 0, and solve it. Well, that one's solved for you. So that has 4 different solutions. So your sketch of it, you would say it's going through 0, -3, -5, 1, 2, 3, 4. You know that this is positive, so they're both 1, 2, 3, so it's going to be pointing up. And then you kind of just got to work this out. So there you go, something like that. Once again, you're not really worried so much about the heights, you're worried about the zeros and the end behaviors. Now, if you have something like this right here that isn't broken down like this, then you have to go ahead and factor it. So it should be set equal to 0 because we're trying to find the zeros. I can factor this the short way because I don't have a number here. So I can go straight into my factored answer. I'm gonna break that down. This tells me that my signs are the same. I put my factors of 10. Everything's going to be positive. Doesn't really matter which parentheses I put that in since everything's positive. And then I have to set them equal to 0 using the 0 product property. And those are both of my solutions. Okay, and we know that that's quadratic. So this one we know a little bit more of how to graph that, but once again, if they're just asking for what the solutions are, you don't have to graph it. Okay, and then also if they ask you for the solutions and it's a picture like this, we did this at the very, of yesterday's lesson, but you would just look for the zeros. So you have a 0 at -3, you have a 0 at -1, and you have a 0 at 3. So those would be your solutions. So graph's really easy. And then please do not forget your transformations. So you might want to go back to the lesson that had that on there, but don't forget up, down, left, right, all of those things. You want to make sure you know that your transformations before you take the test. Okay? So good luck taking the test. Remember, if you take it on time, you get 2 tries. So try to take advantage of that. Good luck.